right, 4.6 is about polynomial and rational inequalities. So talking about inequalities, a quick, easy example. Say I have this inequality. What do we mean by solving an inequality, right? So if we solve this, you subtract 2 on both sides. You have x is greater than or equal to 1, and your solution set is all the numbers that is greater than or equal to 1, right? So something like that. All right, so solving an inequality is to find all the possible x values that satisfy the inequality. So similar for solving a polynomial inequality or solving a rational inequality. Okay, so we will talk about 2 methods today. One method is solving it by using a graph, and the other method is to solve it just by pure calculation by algebra. All right, so if we want to solve it by using a graph, let's look at this example. You can see the graph, right? Can you guys see the graph?
Yes.
Okay, so we want to solve, so we're given a function f of x, right, and the graph. We want to find out when f of x will be less than 0, right? So we want to find all the possible x values that make f of x less than 0. Okay, so if you look at the graph, y is just f of x, right? Basically, we want to find all the x values that makes y less than 0. So when is y less than 0? Can you tell y is less than 0? Like just on these intervals, like this part and that part, right? So what is the corresponding x values to it? Well, you can tell it's from -1 to 1. It's in between here, and also from 2 to infinity. Right? So the solution or solution set to this inequality is, first of all, is from -1 to 1. Do we include -1 or 1?
Yes.
Well, pay attention here. It's less than 0, right? So if you include -1, that means when x is equal to -1, f of x is equal to 0, right? That doesn't satisfy the inequality. So you shouldn't include -1 or 1, because -1 or 1 are making f of x equal to 0. Union this interval, which is from 2. Also, 2 is not included because 2 makes f of x equal to 0 to infinity. So that's the solution to the A part. Questions on this part? All right, so on your own, try to find what is the solution for this inequality. F of x is greater than or equal to 0. Right. It shouldn't be very bad. If you see the graph, it should be this part is when f of x is greater than or equal to 0, right? And this part. So first of all, you have to agree that your solution needs to include these 3 points, these 3 x-intercepts, because those 3 x-intercepts make your f of x equal to 0, right? And then it's the part above the line. Okay, so the solution should be from, first of all, is this part, -infinity to -1. Well, is -1 included? Yes. Union, then this interval. From 1 to 2, well, 1 is included, 2 is also included. Right. Questions on this problem? So if you're given a graph it's pretty easy to find the solution. Right? So let's look at another example. So this is a graph with vertical asymptote and horizontal asymptote. Well, it's pretty much the same, right? So find a solution where f of x is less than 0. You can mark it on your graph. When will f of x less than 0? It's kind of like, so first of all, your solution shouldn't include that x-intercept, because that x-intercept is making f of x equal to 0. Right? It's this part and this part. So for A, the solution should be, what is from here to here? It's from, you have vertical asymptote of -1, right? So from -1, well, -1 should not be included because -1 is not even in the domain. Right? X cannot be equal to -1. From -1 to 0, that's one part. Union this part. This part is from 1. Well, your x cannot be equal to 1 because 1 is obviously not in the domain. 1, 2, all the way to infinity. That is the solution for f of x less than 0. Any question on that part? Somebody's mic is making a lot of noises. Okay, great, perfect. All right, any questions on the A part? So let's look at B. So for B, we want to solve for the inequality f of x is greater than or equal to 0. Let's look at the part where f of x is greater than or equal to 0. So first of all, you have to include your x-intercept because that is making your f of x equal to 0. Right? What else is included? This part, right? Where else? The graph is greater than 0, this part. Okay, so to write the solution to make f of x greater than 0, it's from -infinity to all the way to -1. Well, -1 should not be included because -1 is not in the domain. Right? Union this part, which is from 0, where 0 is included, because 0 is making y 0, right? And to 1. That will be the solution to f of x is greater than or equal to 0. Any questions on giving you a graph, how to read the graph and solve an inequality? Have questions in that? All right. So moving on to next problem is solve this equation. Solve f of x is less than 0 where f of x equals -1/2 times x plus 4 times x minus 1 cubed. If you want to know, this is in the textbook number 14. Okay. All right, so how do we solve this inequality? Right. So another way, well, one way to do it is to graph the function f of x. Graph the function f of x and then read the graph. So we're going through that method now. First, graph f of x. All right, how do we graph f of x? We want to find x-intercept. Right. So x-intercept. What are the x-intercept? And I also want to know the multiplicity. That helps me graph multiplicity. Okay, so what are the x-intercepts here? X-intercept here, what makes f of x equal to 0? Well, we have three factors. One is negative 1/2, right? One is x plus 4. One is x minus 1. X minus 1 is a factor up here 3 times. So one x-intercept coming from here, which is negative 4. Right. One x-intercept coming from here, which is positive 1. And the multiplicity here is 1 and 3. Okay. Y-intercept. Now y-intercept. What is y-intercept? Well, make x equal to 0. What is f of 0? That is negative 1/2 times 0 plus 4. 0 minus 1 cubed. Negative 1/2 times a positive 4 times a negative 1. Right, so negative times negative, positive, positive 2. So 0, 2. Okay, that's the y-intercept. Now, what else? And behavior. So how do we know the and behavior of a polynomial? The and behavior assembles the leading term, right? So what is the leading term? Leading term, let me write this again. The leading term is, first of all, negative 1/2, that's the coefficient. Do you agree the leading term is negative 1/2 x cubed? That's the leading term. If you distribute everything, the first term, the leading term, with to the fourth. Sorry about that. So the term with the highest degree will be negative 1/2 x to the fourth. Any questions here? No? Good? All right, I'm hearing absolute silence. Can you guys hear me? Okay, great.
Yeah.
All right, so the and behavior assembles y equals negative 1/2 x to the fourth. So the graph of negative 1/2 x to the fourth will be, first of all, x to the fourth. It's a U-shaped, and it's negative. It's like something like this, right? And the and behavior will be like this, right? That will be the and behavior of this f of x. Okay, I believe I can start graphing. I just need a rough graph to help me find my solution to this inequality. So first x-intercept, negative 4, let's say here, 1, let's say here, 2 x-intercept, 1 y-intercept, which is 2. So 2 is here. All right, and then using my and behavior, my and behavior will be like this, right? Like this. All right, so starting from here, going up, somehow I have to touch this negative 4. Am I passing it or touching it? Well, based on the multiplicity, it's odd, right? You have to pass it. Well, somehow you have to go back here again, right? And then somehow you have to go back to this x-intercept 1. We're passing that x-intercept because the multiplicity here is also odd. Right? If it's even, it will go up, but it's odd, it will go down. This is a rough graph, right? But it helps us solve this inequality. So for f of x, what is our problem? F of x less than 0, the solution should be this part, right? Right? So the solution should be negative infinity to negative 4. Is negative 4 included?
No.
No, right? Because when x is equal to negative 4, your f of x is equal to 0. Excuse me. And union, the other interval will be from 1, right, to infinity, where this 1 is also not included. So this is the solution to f of x less than 0. Questions on how to solve an inequality by graphing? All right. Okay. So similarly on solving rational inequality, I won't graph a rational inequality and then solve it. You got the idea, right? You graph your rational function, and then based on the graph, you can decide where your solutions are. Okay, any questions on this part? Solve inequality by graphing. Okay, so then we will move on to how to solve the inequality without graphing. Right? How to solve it by calculating through calculation. So let's look at this problem. I wrote number 19, number 20. So if you look at number 20 in the textbook, you don't have to. I'll write it down. X minus 5 times x plus 2 squared greater than 0. All right, so how do we solve it without graphing? Right. So first, for a polynomial inequality, you want to find all the real zeros. Basically, find the solution where one side is equal to 0, the other side, the solution to the other side, basically. So solve x minus 5 times x plus 2 squared equal to 0. So here we have how many solutions?
2.
2. One solution is this 5, right? The other solution is this negative 2. Okay. So those two numbers, do you agree those two numbers will make this expression equal to 0? Of course, that's the solution to it, right? All right, so on my number line, I'm going to mark those two numbers in the order of number line. So negative 2 should be on the left because that's smaller, and 5 is on the right. Mark it like this first. All right. So first of all, do you think our solution would include negative 2 or 5? Will our solution have 5 or negative 2 in it?
No, because it's greater than, not greater than or equal to.
Yes, so these two numbers will make that expression equal to 0, right? We want to find when will be greater than 0. So first step, those 2 points are not solutions. Okay, so we want to know when x minus 5 times, wait, let me erase this. X minus 5 times x, that's fine. X plus 2 squared, when will that be greater than 0? Okay, so first of all, these two numbers are separating our whole number line into 3 sections. I don't know if you can tell. So here is from negative infinity to negative 2, right? So from here to here is from negative 2 to 5, and from here is 5 to infinity. All right, so we want to decide which interval will be the solution to the original inequality. Okay, sorry, I still want to delete this. All right, so what I will do is pick a test point. Pick a test point from each interval. And if that test point make the expression positive, then the whole interval will make that expression positive. if that test point is making the expression negative, the whole interval will make the expression negative. Okay, so test point. So I will pick a test point from each interval. So between negative infinity to negative 2, I will pick just a small enough one, negative 3. Right? Pick a test point from negative 2 to 5. Since 0 is in it, I always like to include 0. Between 5 to infinity, I will pick a point 6. Right, that's in the interval. Then I'm going to plug in these 3 test points into the expression. Now I'm going to write this again. X minus 5 times x plus 2 squared. To see if each test point is making this expression positive or negative. Let me draw a little table here. Okay, so plug in negative 3. Since I only want to know positive or negative, you don't have to find the exact value just to see if it's positive or negative. So if I plug in negative 3 in this expression, well, negative 3 minus 5 and negative 3 plus 2 squared. Okay, this is negative, right? Times this is negative squared, which is positive. So overall, it will be negative, correct? All right. Any questions on this part? So negative 3 will make this expression negative. That's all I care. Good so far? Okay, so now let's test for 0. 0, if you plug in 0 there, 0 minus 5 and 0 plus 2 squared. 0 minus 5 is making it negative, and 0 plus 2 is positive. Positive square also positive. Then negative times positive is a negative number. I don't care what the value is. It's negative. All right, now on 6. You plug in 6 there. 6 minus 5, 6 plus 2 squared. This is positive times positive. Overall, it's a positive. Okay. Now go back to our problem. Our problem wants to know when this expression will be positive, right? The interval we found is this interval. This interval is making that expression positive. The other two are making it negative, right? So our solution should be from 5 to infinity. Plus, we're not including those two x-intercepts, right? So the solution 5 to infinity. Any questions on this problem? All right, now let's look at a problem number 24 in the textbook. So right over here. 24. Okay, so 24 is too small. You know what? Let me move it up. So number 24 goes like this. And 3x cubed less than negative 15x squared. Okay. We want to solve this inequality, right? The first step is you want to make one side equal to 0 so we can factor, right? So I'm going to move this to the other side. So add 15x squared to the left side. I have 3x cubed plus 15x squared less than 0. All right. In order to find all the zeros, I need to factor. All right, so factor on this expression on the left side. What should I factor out? What is the GCF?
3.
3 and?
3x.
X squared, right? 3x squared is the greatest common factor. All right, factor it out. So first term inside the parentheses will be 3x cubed divided by 3x squared, x. Then obviously it's plus 15 divided by 3, 5, x squared divided by x squared, 1. Right, so I can factor this polynomial like this on the left. All right, so what are the zeros here? What makes the left side equal to 0? There are two x values. Right? One is from here, 0. The other one is from here, -5. Right? Okay, now I'm going to mark those on the number line. -5, 0. Okay, so these 2 points are separating your graph into 3. Oh, I should pick one with the equal sign. That's fine. From -infinity to -5, that's one interval. From -5 to 0, that's another interval. From 0 to infinity, that's another interval. And will my solution include those two zeros? Will my solution include -5 or 0?
No.
No, right. Oh, put empty point, empty circle just to show my solution won't include those 2 points. Okay, now I'm going to pick a test point from each interval. Okay. -6, I guess. Here, -1. Here, 1. Just like to put barely enough. Okay, then I want to decide if each test point will make what expression? This expression, positive or negative, right? We want to find the one to make this negative. Okay, so I want to test 3x squared times x plus 5. If each test point will make it positive or negative. Okay, so first test for -6. -6, plug in here. Do you agree whichever number I plug in, x squared will always be positive? So I won't test over there. 3 is negative, x squared is negative, 3 is positive, x squared is positive. All I need to test is if x plus 5 is positive or negative, right? If it's positive, it's positive. It's negative, it's negative. Okay, plug in -6 here. That's negative. Plug in -1 there, -1 plus 5 is positive. It will be positive. Plug in 1 plus 5 positive, and then will be positive. Okay, so the interval I'm looking for should be, which interval? Which interval is making the 3x squared times x plus 5 negative?
-infinity to -5.
Very good. So this is the solution. The solution is -infinity to -5. That's the answer. Questions on this problem? So it's a pretty similar problem. The only difference is you have to factor yourself, right? The first example, they factor it for you. This example, you have to factor yourself and then find zeros and then do the calculation. Okay, next problem. Let me see, next problem is, what did I write down? 26, well, yeah, let's look at 26. Okay. So 26 in the textbook goes like this. X plus 1 times x plus 2 times x plus 3 is less than or equal to 0. Right. So we'll just follow the same procedure, right? How many zeros do we have? Well, 3. What are they? -1, -2, -3. Since one side is already equal to 0. Okay, so on the number line, you have to mark these 3 points. -3 on the very left, then -2, then -1, in the right order of the number. Okay, now the the number line is separated into 4 intervals, right? One is negative infinity to negative 3, negative 3 to negative 2, negative 2 to negative 1, negative 1 to infinity. All right, we want to decide which interval will be our solution. Also, for the x-intercept, for these 3 points, are those going to be part of the solution or no?
Yeah.
Yes, so no matter what our answer is, I need to include these 3 points. Okay, then it's pretty similar. Now, pick a test point in each interval. This one negative 4, this one is between negative 2.5. This one negative 1.5. Here 0. Okay. What do I want to test for? I want to test for if x plus 1 times x plus 2 times x plus 3, if each test point is making that positive or negative. So first, plug in negative 4. Negative 4 plug in here is negative. Negative 4 plug in here times negative, also negative 4 plus 3, negative. Negative times negative is negative. First of all. Second one, negative 2.5 plug in here, negative. Negative 2.5 plug in here, negative. Negative 2.5 plug in here, positive. So overall, positive. Negative 1.5. Negative, plug in here, positive, right? Plug in here, also positive. So overall, negative. Plug in 0 here. 0, plug in, that's 1. 1 times 2 times 3. Overall, positive. All right. So my solution intervals should be, let's see, I want it to be negative. So negative is this interval and this interval. Right. So my solution should be those 2 intervals plus the points. So what is my solution? From negative infinity to negative 3, well, this negative 3 needs to be included. Union, negative 2 and negative 1 needs to be included. So closed interval, negative 2 to negative 1. Right. Any questions to this problem? Right. So next, 20, 34. Okay. So far we talk about how to solve a polynomial inequality. How about it's a rational inequality like number 34, solve this inequality. Is greater than, let me make it equal to 0. Okay, now 34 is just greater than. I changed the problem, so this is not number 34. All right, so we want to solve this inequality. All right, so what are the significant numbers on the number line? Well, you need to find the zeros from the top and the zeros from the bottom. So the 0 from the numerator, or zeros from the numerator. Well, 0 from the top will be 3, right? 0 from the bottom, the denominator, in our case is negative 1. So 3 and negative 1 are the 2 points on the number line. So the 2 numbers on the number line will be negative 1 and 3. Okay, so now first let's decide if these 2 points will be part of the solution. So first of all, let's look at negative 1. Will negative 1 be part of the solution?
Yes.
Think again. Plug it back in.
No, it
No.
won't. 3
Right.
will.
Yes. So -1 will not be part of the solution because -1 will make the denominator equal to 0, right? It's not in the domain. So that's not part of the solution, but 3 will be part of the solution because the 3 will make the whole expression equal to 0. Okay. So now, then the rest is pretty similar. You want to find the intervals first from -a to -1, then from -1 to 3, from 3 to infinity. That's the 3 interval. These 2 points are separating the whole number line into. Now test point. Test point, I'll pick -2, pick 0 here, and pick 4 here. Just any test point as long as they're in the interval. So now I want to test if x minus 3 over x plus 1 is positive or negative in each interval. So testing for -2. -2 plug in on top, it will give it negative over the bottom is negative. Negative divided by negative, it's positive. Okay, so for 0, top is negative over the bottom is positive. So negative divided by positive, negative. Right, third, plugging 4, positive on top, positive at the bottom. So overall positive. All right, so which is the interval we want to take? It will be making the whole thing positive or 0, right? Positive. So it will be this interval or that interval. Right, so summarize your solution. Your solution should be from -infinity to -1. That's one interval. Union, here you need to include this 3. So 3 to infinity. All right, that's the answer. Questions on this? Any questions on this problem? Okay. No? Okay, let's see. 30, 40. 40. Okay, there it is. Do you guys want to do a practice one, or you want me to just keep going? Do you want to do one for practice?
Go ahead.
Okay, so let me write down number 36 as a practice. Actually, it is a little bit different. X minus 3 times x plus 2 over x minus 1 is less than or equal to 0. Solve this inequality. Give you guys about 3 to 4 minutes.
Is it supposed to be positive or negative?
What do you mean? Less than or equal to 0?
Is the target interval, or is what's the
What's the 3 points? Well, oh,
I mean,
you want me this? Will this be? Do I want this to be positive or negative?
yeah,
Negative, because it's less than or equal to 0. Less than or equal to 0 means negative or 0, right? Am I making sense?
yeah.
Okay. Okay, let's take a look. So first, since this is already factored, one side is equal to 0, right? I just need to find the 0 from the numerator and the 0 from the denominator. Well, the 0 from the numerator will be, what are the zeros from the top?
3 and -2.
Very good. So 3, -2, and 0 from the bottom. Is
1.
1. Okay, those are the three numbers on the number line. So the smallest is -2, the one in the middle is 1, the greatest is 3. So first, let's decide if any of these 3 points will be part of the solution. All right, so -2, is it part of the solution?
Yes.
Yes, okay. 1?
No.
No. 3?
Yeah.
Yes, okay. So first mark it like this. Okay, now the interval, let's mark the interval from -infinity to -2, from -2 to 1, from 1 to 3, and from 3 to infinity. Let's see which interval will be the solution. So now pick a test point from each interval. Okay, I'll pick, you can pick whatever you want. I will just pick these 4 numbers. I plug it into this whole rational expression, the whole left side. Right? I want to see if each test pointer will make this positive or negative. So plug in -3, negative times negative over negative. That's overall, it's negative. Here, 0, that's negative times positive times negative over negative. So it's positive. Over here, it's positive times positive over positive. Okay, overall positive. Here 3. Sorry, 4. Did I do 2 right? No, 2 is wrong. Sorry. I was looking at something else. So 2 minus 3 is actually negative. Negative, positive, positive. So actually it's negative over here. Sorry about that. So last one, it's positive times positive over positive, positive. Okay, and we want to know when will this expression be less than 0, which is the negative. Right, so it will be this interval and this interval plus those 2 points. Right, so to sum it up, you should have from -infinity to -2, -2 will be included, union from 1 to 3, where 3 is included. Right. Any questions on this problem? Okay. Great. Sometimes you have to factor the numerator or the denominator by yourself. Just you may see those kind of probably in the homework. Okay, now let's look at number 40. Number 40 goes like this. X plus 2, you know what, I want to change the problem. Over x minus 4 is greater than or equal to 3. I want to change to 3 instead. All right, so let's solve this inequality. All right, so first of all, the right side is not equal to 0. We want one side equal to 0. The other side is the something over something form. Okay. So now first we need to move the 3 over. So one side could be equal to 0. Right? Subtract each side by 3. So we have x plus 2 over x minus 4 minus 3 that is greater than or equal to 0. All right. After we do that, we see, okay, it's not one fraction. It's a fraction minus a number. So we want to turn the left side into one fraction. So we need to find the common denominator and do the subtraction. Okay, 3 can be seen as 3 over 1. Right, between 1 and x minus 4, the common denominator is the common denominator.
X minus 4.
X minus 4. Right, so we need to turn this y into x minus 4 by multiplying it by x minus 4. Do the same on top. So these two cancel out to be the original number, right? 3. Okay. Now that we have the common denominator, which is x minus 4, which stays at the bottom, we can subtract the top. The top becomes x plus 2 minus 3 times x minus 4. All right. Now, let's simplify the top. All right, so I will do it on the side. Save us some 3x minus 3x plus 12. Combine like terms, that's negative 2x plus 14. And if I factor out the negative 2, I have x minus 7. Why do I need to factor? You don't have to in this case. It's pretty easy to tell what's the 0 on top. I just like to factor everything you see. Anyway, simplify the top like that, negative 2 times x minus 7. Any questions so far? All right, great. Now zeros from the bottom. Not right. So the two significant numbers will be 7 and 4, right? We'll just draw the number line. The number line should have 4 and 7 on it. Because 7 is 0 from the top, 4 is 0 from the bottom. Okay, so should we include 4 as our solution?
No.
No. 7?
Yeah.
Yes, okay. Now, negative infinity to 4, 4 to 7, 7 to infinity, 3 intervals. Now, test point from each interval, we have, I just love 0, 0, 5, and 8. Let's see, any number you want, as long as they're in the interval. Now, test, I want to test, what do I test? Do I test if this is positive? No. We want to test if this is positive or negative, right? So make sure you write negative 2 times x minus 7 over x minus 4. We want to find out if this is positive or negative. So negative 2, let me make them smaller so you know what I'm talking about. So x minus 7 over x minus 4. Okay, so plug in the test point. Negative 2 is always negative. Negative times negative over negative. So it's negative. Plug in 5. Negative 2 is negative. Negative times 5 minus 7, negative, over positive, which is a positive. Plug in 8. Negative 2 is negative times positive over positive. So overall, it's negative. Okay, we want to know when this expression will be positive, right? So that will be this. Well, talking about this interval. So your solution should be from 4 to 7 with 7 included. That's the solution. Right, questions? No questions? All good, okay. Now, next problem I want to go over is number 44. So number 44 in the textbook goes like this. 5 over x minus 3 is greater than 3 over x plus 1. All right, this one looks pretty complicated. Well, our goal, well, first thing we want one side to be 0, right? The other side is 1 fraction. So first thing we do, let's move everything to one side. So I will move the 3 over x plus 1 to the left side. So first step, this is what I get. All right, now I need the left side to be 1 fraction. Now it's 2 fraction. Right, to make it 1 fraction, I need to, again, find a common denominator. So what is the common denominator between x minus 3 and x plus 1? What is the LCD here?
X minus 3 times x plus 1.
Very good. X minus 3 times x plus 1. Right. So I need to turn each denominator into this common denominator. So make x minus 3, x minus 3 times x plus 1. You need to multiply x plus 1 to the top and to the bottom. Similarly, if you need to multiply the second fraction by negative 3 on top and at the bottom to make the denominator the common denominator. Right, now the denominator becomes x minus 3 times x plus 1. The top part is 5 parentheses x plus 1 minus 3 parentheses x minus 3. Okay. So somehow I need to simplify the top. So let's simplify the top on the side. 5x plus 1, that's 5x plus 5. Right. Minus 3x, distribute, plus 9. Combine like terms, that's 2x plus 14. Right. I like to factor out the 2. Just that it's fully factored. All right. Now the 3 points on the, now everything is factored. We can find the points on the number line. So the first point, well, the points are negative 7 from the top, right? And 3 from here, and negative 1 from there. Put them in the right order. Negative 7 is the smallest, then it's negative 1, then it's positive 3. All right, any of these 3 points will be part of the solution? No, none of them. Okay. First of all, for the 2 zeros at the denominator, they cannot be part of the solution no matter what. Negative 7 cannot be equal to 0 because we're looking for greater than, without the equal to. Okay, so now number line divided into, in this case, 4 intervals. 3 to interval to infinity. Test point. Test point from each interval. I have negative 8. Here I'll pick negative 2, 0, and 4. Now, what do I want to test? I want to test, do I want to test their original like this? No, you want to test if it is greater than or greater than 0, this part. The original inequality and this inequality are equivalent. They're the same inequality. You just did some algebraic changes to change the form. Okay, so I want to test if 2 times x plus 7 over x minus 3 times x plus 1, if this expression will be positive or negative. Okay, use the test point. 2 is always positive. Well, I'll ignore this 2. Negative 8 plus 7 negative over negative 8 minus 3 negative times negative. Okay, overall negative. Plug in negative 2 positive over negative times negative. So positive. 0 positive over negative times positive. So we're all negative. Here, plug in 4 positive over positive times positive, overall positive. All right. So I want that expression to be positive. So the interval I will choose are these 2 intervals. And those 2, since I don't have to add any additional points, those 2 intervals will be the solution. The solution is this interval union that interval. That's the solution. Any questions on this problem? Okay. Okay, do we want to do a practice problem or you want me to? I have one more problem I want to go over. So do you want me to finish the next one, then we do practice? Or you want to do a practice right now? Your choice.
Go ahead.
Go ahead, do practice, or go ahead to do the next problem.
You can do practice.
Okay, let's do a practice problem similar to this problem over here. Right? Actually, let me write next to it. So let me take a problem similar to that. 43 in the textbook is 1 over x minus 2 is less than, you know what, let me change it to equal to, so you pay attention to the 2 over 3x minus 9. Okay, I'm going to let you work on this problem. So are we done? A bit more time?
Not yet.
Okay. How about now? More time?
So like another minute, I guess.
Okay. Mhm.
Okay.
Okay. All right, so first step, we need to make one side equal to 0. Right? That means I will move 2 over 3x minus 9 to the right, to the left side. Okay, so right now I will factor out this 3 to make it look like that, because that's factorable. All right, so now the common denominator, least common denominator. In this case, it will be, first you have to include this 3. Right? 3 times x minus 3 times x minus 2. This one will be the least common denominator. All right, so now I need to make the first denominator this common denominator. So it's missing a 3 and x minus 3. So I need to multiply 3 times x minus 3 at the bottoms and on top. Okay, now to make the second denominator this common denominator, it is missing x minus 2. I will multiply the bottom and the top by x minus 2. All right, now that they have the same denominator, I can use this common denominator, which is 3 times x minus 3 times x minus 2. On top, it is 3x minus 3 minus 2 times x minus 2. Less than or equal to 0. Okay, let me simplify the top. So on the side, the top will be 3x minus 9 minus 2x plus 4. Combine like terms, that's an x. These two is a negative 5. So x minus 5 over 3x minus 3, x minus 2. That's not equal to 0. Okay, now I can decide the 3 points or the points on the number line. The points are, so zeros, doesn't matter from the top or the bottom, will be 5 right from here, and 1 is 3 from here, and 2 from there. Okay, those 3 are the 3 zeros. So 2, 3, 5. Right. So are those 3, well, will 2 be part of the solution? No, right, because 2 will make the denominator equal to 0. Will 3 be part of the solution? No, because 3 will also make the denominator equal to 0. That's not in the domain. How about this 5? Well, 5 will make the whole thing equal to 0. It is part of the solution. Mark these 3 points. Okay, now intervals. Negative infinity to 2, 2 to 3, 3 to 5, and 5 to infinity. All right, now test point. Test point from the first interval is, I'll pick 0. Here I'll pick 2.5. Here I'll pick 4. I'll pick 6. All right. What do I want to test? I want to test if this expression, x minus 5 over 3 times x minus 3 times x minus 2 is positive or negative under each test point or each interval. All right, so plug in 0, negative on top over 3. I'll just ignore the 3 because 3 is positive. So this is negative times negative, so overall negative. 2.5 negative on top, negative times positive, so positive overall. 4 plug in negative over positive times positive, negative, plug in 6. Positive over positive times positive, positive. So the interval we want will be the ones that making this expression negative. Right? This interval and that interval plus that point. So your solution should be from negative infinity to 2, union from 3 to 5 with phi included. Okay, any questions on this problem? Any questions on the simplification part? Questions?
No.
All right. Now I wouldn't call it the last problem, last type of problem. I saw this problem in our homework. Well, I assigned homework. I just saw this problem generated from the homework. I just a little bit scary, but let's look at this problem together. Right? So first of all, we want to make one side equal to 0. Right? We need to move the 40 over x to the right side. So 40x minus 39 minus 40 over x less than 0. All right. Now I need to find the common denominator. Right. So make everything over 1. The common denominator is x. So I need to multiply an x here. So it becomes x squared. Multiply x here. That's 39x. So that they have the common denominator of x. Right? On top, you have 40x squared minus 39x minus 40. All right. This scares me. I was like, oh, how do you factor the top? Is it even, factorable? Do I have to carry the square root? Then I convinced myself to factor it. So let's factor the top together. That's the scary part. All right, so 40, what makes 40? 5 times 8. And this way, what makes 40? 5 times 8. So write as 8 times 5. This gives you 25. This gives you 64. Their difference is 39. So this is factorable, even though it looks scary. So I need a negative 39. That means the 64 is negative. 25 is positive. So trace it back. 8 times negative 8 will give me negative 64. And check over here. 5 times negative 8 is negative 40. Okay, this is the right combination. So I will factor the top as first row, 5x minus 8. Second factor coming from the second row, 8x plus 5. You can factor in whichever you prefer. All right. Then we're pretty much done. Not pretty much done, but almost done. The zeros, all the zeros from the top are 8 over 5. Right? Make 5x minus 0, 8 equal to 0. You solve it, 8 over 5. And the other 0 from the top is negative 5 over 8. Similarly, you make 8x plus 5 equals 0. solve it. And the 0 from the bottom is 0. Right. 3 zeros here. Okay, now put it on the number line. So negative 5 over 8 is the smallest, 0 is in the middle, 8 over 5 is the greatest. Now let's decide if these 3 points will be part of the solution. The answer is none of them will be part of the solution, right? Because it's less than. We don't need any number to make the expression equal to 0. So now intervals, negative infinity to negative 5 over 8, negative 5 over 8 to 0, 0 to 8 over 5, and 8 over 5 to infinity, 4 intervals. Now test point, here I can put anything, negative 1, here, negative, I'll put 1/2. Here is, oh well, that's not that bad, it's 1, 1 is in that interval, right? Here is, I'll put 2, or 100, any number that's in from 8 over 5 to infinity. Okay, now what do we want to test? I'm going to test 5x minus 8 times 8x plus 5 over x if this expression is positive or negative. Plug in negative 1. Negative 1 times 5 is negative 5, so minus 8 is negative. So negative 1 times 8 is negative, and plus 5 is also negative over negative. So overall negative. Plugging 1/2, negative 1/2. 5 times negative 1/2, negative 2.5 minus 8, negative. Negative 1/2 times 8 is negative 4 plus 5, positive, over negative. Overall, positive. All right, plugging 1. 1 times 5 is 5, 5 is 8, negative. Then positive, overall negative. Plug in 2. 2 times 5 is 10, positive times positive times over positive, so overall positive. Now, which interval or which intervals are the ones we want? We want the whole expression be less than 0. Right? So this interval and that interval. So that's your solution. Negative infinity, negative 5 over 8, union 0 to 8 over 5. That's the solution. Any questions on this problem? Okay. I will let you work on a similar problem to this. Right? It is, let me write it on the side. It's actually 57 in the textbook, if you want to know. Looks like this. 6x minus 5 is less than 6 over x. Give you some time to work on this problem. Are we done?
No, but I'm not really sure what to do after it's factored.
After it's factored, find all the zeros? You're talking about this
Yeah,
step?
but I'm not sure how, because I would have thought that to find the 0, you would just plug 0 in for x, and then it would cancel out the 4, and you'd have -9 and +4. And I would have thought that's what happened in the last one, but it wasn't. I'm not really sure what to do.
Let's look at this together. Maybe when we get to that step, I will see what you're talking about. Let's see. So it's 6x minus 5 is less than 6 over x. Right, so first step, moving that 6 over x over. Now find the common denominator. So need to like this. Right? So x is at the bottom. On top is 6x squared minus 5x minus 6. Now factor the top. The top 6 is factored as 2 times 3. The other 6, 2. Let me write the whole thing down. Now 3 times 2. Cross multiply this. So 4. That's a 9. I need a -5 in the middle. Are you talking about this part? So.
No, I'm past that, but
Okay.
keep going.
So we need a -5 in the middle. That means this 9 is a -9. And 4 is a +4. So trace it back. That's a -3 here. And check over here. That's negative. Awesome. So we will factor this as the top 2x minus 3 from the first row. Second row, 3x plus 2. Okay, over x. The zeros. So zeros from the top. The numerator will be whatever makes the top equal to 0. Right. So if you want to solve 2x minus 3 times, let me erase this, times 3x plus 2 equal to 0, you would have to come up with 2 small equations like this. Right. So solve the first one, 2x equals 3, x is 3 over 2. Solve the second one, 3x is -2, x is -2 over 3. So 2 zeros from the top.
I see. Okay. I did that wrong. I mean,
Okay.
I did it wrong anyways. I got, yeah.
So the denominator, so 0 from the denominator, I will just write the bottom. Okay. Just from, it's 0, right? Whatever makes the bottom 0, it's 0. Okay, so 3 numbers on the number line. -2 over 3 on the very left, middle 0, right 3 over 2. Test the point. Since it's less than, you don't have equal to. None of the points will be included. So now I want to separate the intervals, -infinity to -2 over 3, -2 over 3 to 0, 0 to 3 over 2, and the last one is 3 over 2 to infinity. Now, so -infinity, okay. Now, test point. Test point from each interval here, I will pick -1. Here, -1/2 is there. Here is 1. Here's 2. Yeah, 2 is there. Now, what do I want to test? I want to test if this factored 1 fraction is positive or negative. Right? 2x minus 3 times 3x plus 2 over x. I want to see if this is positive or negative. So put it in, -1. -1 times 2 is -2. It's negative times negative over all negative. Plug in negative 1/2 negative times, negative 1/2 times 3 is negative 1.5 plus 2 positive over negative, right? Overall positive. We're plugging 1, 2 minus 3 negative, positive over positive, negative overall. Plugging 2, 1 minus 3 positive, positive, and positive, positive. And we want that that expression to be, look on top, it's wanted to be negative, right? So for the negative ones, will be this interval and this interval, and your solution is negative infinity to negative 2 over 3 union 0 to 3 over 2. All right, do we have any questions?
I'm a little bit confused on your factoring method. I haven't seen it before, but
Well, you can use whichever method you've used before if you're familiar with the other kind. It's just, this method is what I use a lot, so I'm going to explain with this method. Do you want me to go slower on this again? Like how to factor? How to use my method to factor?
I guess I was using negative 9 and 4. I had 4x minus 9 and negative 9x plus 4.
Okay, so you're using this times that. I'm not familiar with that.
I got the same numbers, but I just used the wrong ones for the equation.
Okay, so I can show it again. So it's minus 5x minus 6. So the bottom. So it's 6x squared minus 5x minus 6. Right? So my method is factor this a and c. Right? It's ax squared plus bx plus c. You want to factor your a and factor your c. So factor this 6, factor this negative 6. Really, I'm factoring this 6x squared. So it will be 2 and 3. Right? So really, I'm factoring it as 2x times 3x. But I just don't write the 2 x's because this looks easier, looks simpler. Anyway, then factor this negative 6. Well, first factor is positive. So 3 times 2. Right. Now I'm going to cross multiply. So if you put the x in, 2x times 2 is 4x. Right. If you cross multiply 3x times 3, that's a 9x. And you want the middle term to be negative 5x, right? That means this 9x needs to be negative. This 4x needs to be positive. So this tells you the 3x needs to multiply to be to a negative 3 to get a negative 9x. And then this combination is good. Let me check over here real quick. It is negative 3 times a positive 2. It's negative 6. So that's the right combination. The first factor should be the first row, 2x minus 3. The second row gives you the second factor, 3x plus 2. I don't know. Does it make sense? Or?
Yeah, that makes sense. Thank you.
Mm-hmm. Welcome. All right, any other questions? All right, if not, I'll call it a day. Again, we won't have any Confer Zoom meeting this Wednesday. What I covered today should be enough to cover homework for due Tuesday and due Thursday, right? All right. Have a nice week.
Thank you.
Mm-hmm.
Thank you.
Right, bye.